Okay, now let's start with question number 3. In question number 3, pure water is very poor conductor of electricity. However, when hydrogen chloride gas is dissolved in water, ions are formed and current flows during electrolysis. Okay. So on dissolving hydrogen chloride, hydrogen ions and chloride ions are formed along with water itself dissociates into hydrogen ions and hydroxide ions as well to a larger extent. And as a result, it will able to flow the current. The overall charge after electrolysis is that hydrogen chloride gas is converted into hydrogen and chlorine. Okay. So here we have a overall reaction. So if I split this, so what I would find that 2 moles of hydrogen ions gaining 2 moles of electron and forming hydrogen gas. In the same way, 2 moles of chloride ion losing 2 moles of electron and forming chlorine gas. So that's what the reaction is taking place during the electrolysis. So when a current of 3.10 ampere is passed through a solution for Y minutes, 351 centimeter cube of chlorine. Here we have a volume of chlorine are produced at anode measured under room conditions. Calculate the number of chlorine molecules produced during the electrolysis. Okay. So for molecules, what we would do? First, we convert the volume into moles of chlorine, and to find the moles of chlorine, it would be 351 centimeter cube as it's a gas divided by 24,000 centimeter cube. Okay. So can anybody divide it and tell me the answer?
Sir?
Yes.
सर ये हम डेसीमीटर क्यूब में कर सकते हैं इसको कन्वर्ट?
हाँ, either way, either if you convert this into decimeter cube by dividing 1000, then you would use 24 in the denominator over here instead of 24,000. You will get the same answer. So can anybody tell me the answer, please?
0.0146.
0.0146 are the number of moles. Okay. Now we have to find the number of chlorine molecules. So these are the moles of chlorine. So if I multiply this with the Avogadro's constant, that is 6.02 exponent 23, I would get the number of moles. Sorry, number of molecules. So can anybody tell me the answer?
8.80 into 10 raised to the power 21.
8.80 into 10 raised to the power 21 molecules of chlorine. So 8.80 into 10 raised to the power 21. Is this understandable to everyone? Now next part. Calculate the total number of electrons transferred to produce this number of chlorine molecules. Okay. So if you look at the equation that I have discussed, which represents the reaction taking place at anode, that 2 moles of chlorine, chloride ions forming 1 mole of chlorine and 2 moles of electron. So from this here, the number of electrons used basically it's a 2 mole, so it means 2 times 6.02 exponent 23 electrons are being used. And for that, the number of chlorine the volume, 1 minute. Okay. So the number of molecules of chlorine must be 6.02 exponent 23. And here the number of chlorine molecules in the experiment are 8.80 exponent 21. And here it would be an X. So the value of X would be 8.80 exponent 21 multiplied by 2 times 6.02 exponent 23 divided by 6.02 exponent 23. So these two would be cancelled out. So 8.8 times 2, 16, 1, 2. Isn't it 1.76 if you calculate? And exponent 22, right?
Yes.
So 1.76 exponent 22. Okay. Then in the next part, calculate the quantity of charge in coulombs of the total number of electrons calculated in one. Okay. So we know if the number of electrons are 6.02 exponent 23, then the coulomb charge is 96500 coulomb. So in the experiment, the number of electrons transferred is 1.76 exponent 22. The coulomb charge would be X. So if we calculate the value of X, it would be 1.76 exponent 22 times 96500 coulomb divided by 6.02 exponent 23. Yes, so anybody solve it and tell me the answer?
Two eight two one.
Okay. So it would be 2821 coulombs. So 2821. Okay. Now in the next part, calculate the time Y in minutes for which the current flows. So for that, we know the expression that the coulomb charge Q is equals to I into T. Sorry, it's uppercase Q. So it is 2821. The coulomb charge is equals to the current I is 3.10 ampere into T. So T time would be equals to 2821 divided by 3.10. Yes, what is the answer over here?
$910.08.
Sorry, can you repeat?
910.08.
910.08, and it would be the seconds. And they have asked you in the minutes, so you have to divide it by 60 to convert into a minutes.
Day 15.
15. So it would be 15 minutes. Is this understandable to everyone? Okay. Now part E. The standard entropies S naught of the three species are given in the table. Okay. Get the change in entropy for the reaction. Okay. We have this reaction over here. And for the reaction, whenever we have to find the entropy, that the change in entropy would be equals to the sum of entropies of the product minus sum of entropies of the reactant. So in product, we have a 1 mole of hydrogen, that is the entropy is 131. Then 1 mole of chlorine, its entropy is 223 minus 2 times entropy of HCl, because there are 2 more. Yes, what would be the answer?
Sir, minus 10.
Minus 10, are you sure?
Minus 20.
Okay, confirm whether it's minus 20 or minus 10.
Minus 20.
Sir, minus 20, sir.
Minus 20.
Minus 20. Okay. Now, the enthalpy change for the reaction is positive 185 kilojoule per mole. Calculate Gibbs free energy. Okay. So the expression for the Gibbs free energy change is equals to delta H naught minus T delta S. Okay. Here, the enthalpy change is positive 185. That is in kilojoule per mole. Then minus temperature, that is 298 Kelvin. They already provided you the temperature in kelvins. Then multiply by entropy, which is minus 20, right? But it's in joule per Kelvin, so you have to convert it into a kilojoules. So you have to divide it by 1000. Now, can anybody tell me the answer?
190.96.
190.96. Okay. 190.96. So it can be round off to 191 if we are writing in three significant figures. So 191. Next part. Predict the effect of increasing temperature on the spontaneity of this reaction. Okay. Right now, if you look, the value is positive, which indicates that it is non-spontaneous reaction, right? So here we have a Gibbs free energy. Here we have a delta H minus T delta S. So it's a positive Here we have a negative, and that is negative as well. So if we increase this value, then if it is increased in that way, that T delta S becomes greater than del H. So the change in Gibbs free energy becomes negative. No, sorry. This is negative and there is a negative in the formula, so it would become even more positive. So the reaction become even more less spontaneous or more less feasible. So we would write that the reaction gets less spontaneous at higher temperature because that the minus T delta S becomes more positive and delta H is also positive. So both the values gets positive. We will get a more bigger values with the positive sign. Is this understandable to everyone? Yes. Now, here we got question number 4. Separate samples of 0.01 mole of magnesium nitrate and 0.01 mole of strontium nitrate. Magnesium nitrate is MgNO3 twice, and strontium nitrate is SrNO3 twice. Are heated until completely decomposed to a metal oxide, nitrogen dioxide, and oxygen. So here we will get magnesium oxide or strontium oxide and nitrogen dioxide and oxygen gas. State which of these groups, state which of these two group 2 nitrates require the higher temperature before it begins to decompose. Explain your answer. Okay. So if you look in the periodic table, in group 2, the first element is beryllium, then the next one is magnesium, then the next one, and then the next one is strontium. And after strontium, we have a barium and then radium, right? Okay. So, for example, if magnesium ion have a this much in size, then strontium ion must be have a that much size bigger. So magnesium actually distorts the negative ion greater, and here the distortion would be less. So in this case, the oxygen-nitrogen bond gets weaker as its bond length increases, and here the bond length of oxygen and nitrogen is not that much big, so this bond is stronger. So it means for strontium nitrate, the higher temperature is needed to decompose. So strontium, okay, 1 minute. If you have any problem in this explanation, see over here. Basically this happens. See, if you look at this ion have a very high charge density because of its size. Is this understandable?
Yes, sir.
And here its charge density is relatively lower. So magnesium ion attracts the carbonate ion, this carbonate ion with a stronger force. As a result, see what happens to the shape of the carbonate ion. It gets distorted and this bond length increases, and as this bond length increases, this bond gets weaker. So it would be very easy to break this bond at a lower temperature, and as a result we would get magnesium oxide and a carbon dioxide gas. Is this understandable?
Yes, sir.
So here if you see, the size of a cation is a bigger, so the distortion is less, so the bond length is lesser than the bond length that was in magnesium carbonate, due to which this bond becomes stronger, and hence to break this bond we need a high temperature or a higher temperature. Is this clear now?
Yes, sir. Thank you.
Okay. So strontium nitrate requires the higher temperature to decompose, because the strontium ion is bigger in size than magnesium ion. So the nitrate ion is less distorted, less distorted. Hence, nitrogen oxygen bond is stronger in strontium nitrate. Is this understandable?
Yes, sir.
Okay. Now, B part. After decomposition is complete, the 0.01 sample of magnesium oxide is taken and increasing amount of water are added to it with stirring until no solid remains. Okay. So we continue to add water in that magnesium oxide until all the magnesium oxide dissolve. This procedure is repeated with 0.01 mole sample of strontium oxide as well. So let me recall you when in you add water in magnesium oxide, it would dissolve to form magnesium hydroxide. And here, when we add water in strontium oxide, it would also form strontium hydroxide. So if you recall the solubility of group 2 sulfates, the solubility of group 2, the solubility of group 2 hydroxides, the solubility of group 2 hydroxides increases down the group, which means it is less soluble and it is more soluble. Is this understandable to everyone? Now, identify the sample to which the most water must be added to cause all the solid to dissolve. Yes. Who can answer this? Explain your answer by reference to the solubility is added to the oxide. You should refer to the relevant energy terms in your answer. Okay. So if magnesium hydroxide is less soluble, so we can say that magnesium oxide needs more water to dissolve because magnesium hydroxide form is less soluble than strontium hydroxide. Is this point is understandable to everyone? Yes.
Yes, sir.
Okay. Both the enthalpy change of, both the lattice energies and enthalpy change of hydration decreases from magnesium 2 positive to strontium 2 positive. But the lattice energy changes or decreases with the greater magnitude hence the enthalpy change of solution for strontium hydroxide gets more exothermic, and that is the reason, if you recall, the more the exothermic or the more the negative the enthalpy change of solution, the more the soluble that compound is. Is this clear to everyone? Or further you want to add, you can add that making strontium hydroxide more soluble than magnesium hydroxide. Okay, now next part. The nitrogen dioxide NO2 given off by the decomposition of 0.01 mole per dm cube strontium nitrate is dissolved in water. Okay, this is basically dissolved in water. The oxidizing agent H2O2 is then added to give 150 centimeter cube of a solution in which nitric acid is the only nitrogen containing product. Okay. Okay. So what would happen first? That NO2 is dissolved in water. And then H2O2 would add it to form HNO3. So if you take the ratio of these two nitrogen containing products are exactly the same. So it means that if the number of moles, okay, first we have decomposed 0.01 mole per, okay. So let's have a look at the equation. So if I write the equation for the decomposition of strontium nitrate, it would give me 1 mole of strontium oxide, 2 moles of nitrogen dioxide, and half mole of oxygen. So here I can see that the ratio is 1:2. So if I have added or decomposed 0.010 moles of strontium nitrate, then twice of 0.0100 moles of nitrogen dioxide would form. So if we take the ratio of nitrogen dioxide and nitric acid, they are same, which means the number of moles of nitric acid are actually equal to the number of moles of nitrogen dioxide, which are actually 0.0200 mole. If I have to find the concentration of this nitric acid, so it would be the concentration of nitric acid would be equal to the number of moles divided by the volume, which is 150 divided by 1000 to convert it into a dm cube. Kindly solve it and tell me the answer, please. And if anybody have any issue, kindly ask. Yes, what is the answer?
0.13.
0.13. So the concentration would be 0.13 mole per dm cube. Okay. Now the next part. The nitric acid present in 25 centimeter cube of this solution. So it means we have initially 150 centimeter cube of a solution having a concentration of 0.13 mole per dm cube. That's what we have found in the previous part. From that 150 centimeter cube of a solution, 25 centimeter cube of a solution is taken out, and this solution is neutralized using 0.125 mole of sodium mole per dm cube of sodium hydroxide. What they are asking? Calculate the minimum volume in centimeter cube of sodium hydroxide needed. Give your answer to 3 significant figures. Okay, first you may write the equation of the acid and the base that they are reacting to get the mole ratio. So if we would see that they are going to form sodium nitrate and H2O. And if you look at the equation is balanced. So it means the moles of these two would be the same. So first what I will do, I will find the moles of sodium nitric acid which are exactly equal to the moles of sodium hydroxide, and that can be calculated by multiplying the volume that must be converted into decimeter cube times the concentration. So can anybody calculate it? Yes, please.
3.3 into 10 to the power minus 3.
3.3
3.
into 10 raised to the power
Yes,
3.33.
3.33. Yes.
Okay. So 3.33 into 10 raised to the power minus 3 are the moles of sodium hydroxide. We have a concentration of sodium hydroxide. We know the formula that number of moles is equals to concentration times volume. So if I have to find the volume, I have to divide the number of moles with the concentration. So it would be 3.3 exponent minus 3 divided by the concentration, that is 0.125. Yes.
Sir, I'm getting
Yes.
3.25.
You are getting
3.25 exponent minus 3.
3.25 exponent minus 3. Okay. Can anyone recheck? It's
I use the
25.
exact value of moles, the 0.133. It is continuously 3 instead of rounding it off.
So you have
If you
to
round it
convert
off,
the concentration.
Okay. 1 minute. Let me check. We have initially 0.02 divided by 150 and divided by 1000. 0.02 divided by 150 divided by 1000. So 0.1333. Yes, the actual value is 0.1333. It's continuous times 25 divided by 1000. Yeah. So that would be the more appropriate answer, Alishba. 3.33 exponent minus 3. And I have to divide it by 0.125 to convert it into a volume. Yes, can anybody tell me the volume from this value?
So 2.6 times 10 to the power minus.
It is just 2.6.
Say
Times 10 to the power minus 5.
0.266.
Into 10 raised to the power minus 3. And that is a decimeter cube. So you have to convert it to a centimeter cube over here. So multiply this by 1000 would give you 26.66667. So I just write 26.67. Okay. Is it clear to everyone over here? Yes. Okay, just to let you know that, see, the battery is only 2%, so it is going to be, you know, power off soon. So as it will get off, our class will be finished for today. Okay. Actually, I forgot the cable at school. So now we have a question number 5. Okay. Transition element forms complexes. Molybdenum MO forms an octahedral complex consisting of one molybdenum atom surrounded by carbon monoxide molecules. CO is a monodentate ligand. Iron forms an octahedral complex consisting of one Fe3 positive ion and a number of cyanide ions. Cyanide ion is a monodentate ligand. Okay. So the complex of the molybdenum have a this that MO, and they said that it's an atom. So CO6, and there would be no net charge over there because molybdenum have a no charge and carbon monoxide is also a neutral molecule. In case of iron, as iron have a Fe3 positive and it is bonding to cyanide and forming an octahedral. So again, 6 ligands would attach. And here the cyanide have a 3 positive charge and these 6 ligands have a -6 charge. So the net charge would be -3. I hope is this understandable to everyone. Now, define the term monodentate ligand. So I can say a ligand which forms only one dative bond to a metal atom or ion by sharing a lone pair of electron. Is this understandable to everyone?
Yes, sir.
Okay. Now complete the table by stating the formula and charges of the complex described. Okay, just give me a second, please. Just a second. This. Okay, so we already figured out the formulas. So here the formula would be MOCO6 and the charge would be 0. And here the formula would be FeCN6 and the charge would be 3 minus. Is this clear? Okay, now next part, draw a 3-dimensional diagram to show the shape of this iron 3 complex. Label 180-degree bond angle on your diagram. Okay, so we know when we have to draw the octahedral shape, we show 2 bonds exactly on the plane, 2 bonds coming out of the plane, and 2 bonds going back of the plane, right? And here we have a cyanidine. So I would bond a carbon of every cyanidine with the transition metal. Then as it's a ion, so I would enclose it in a square bracket and putting a 3 negative charge over here. And they have asked you to label the 180-degree bond angle. So it could be this. Any two opposite angles can be labeled. Is this clear to everyone? Okay. An excess of aqueous ammonia is added to dilute copper 2 sulfate solution. A dark blue complex is formed. Write an ionic equation for this reaction. Okay. So it's an dilute aqueous copper 2 sulfate, which means it's an aqueous. So if it's an aqueous, so here copper actually existing as a hexa aqua copper 2 complex. And as we see that there are 4 ammonia molecules bonded. So here I would show 4 ammonia molecules. Then in the product, I would show write the formula that is provided in the question. Having 4 ammonia molecules and 2 water molecules with a 2 positive charge and 4 water molecules over here. Is this clear to everyone?
Yes, sir.
Okay. Explain the origin of the color in copper 2 complexes. Okay. So we know that first what would happen when in the complex the ligand bonds with the ligand bonds datively with the metal, the d orbitals split into 2 different energy levels. Then electron at lower energy is excited to higher energy by absorption